All right, guys, if this is really hard, you shouldn't be talking. Be quiet. If it was easy, great. You still need to give everybody else a chance to understand it, okay? So, as I mentioned, these equations are the relationship communicator for how you get y when you know x, or how you get x when you know y. Simply put, they just relate the two values. Now, as I mentioned at the beginning, there's two variables, and this is going to indicate that there can be an infinite number of solutions. That is why we represent them with graphs, not just x equals, y equals, okay? But again, this particular equation says, hey, whatever x is, if you plug a value in here, when you subtract 3, it'll tell you the value of y. So a test would be, hey, let's substitute x equals 9. So if I were to plug in 9, or using a word from a previous lesson, evaluate, then what would I get for y when x equals 9? 9 minus 3 is 6. So that tells me something. That tells me that the point 96 would be on the line of the graph for this equation. Remember I said the line, whatever it is basically just the collection of all the solutions which we can represent with points. But if you have a point everywhere, you don't see the points anymore. If they all get connected, you instead see a line. Okay? So, that's the first thing to understand, is that this represents some line that we'll graph in a second. We can plug in a number for x and calculate the value for y that corresponds. So that's what is meant by the relationship between the variables. So the first thing we're going to do after understanding that is choose the table that communicates that information. So in the table, what I should see is that for any particular x value, the y value is simply that number subtracted by 3. So 0 minus 3 is not 1. That's not the right table. Negative 2 minus 3 is negative 5. That could be the right table, but I better check a second point. Otherwise, I can't be sure. So I'll check 5 too. 5, plugged in for x, 5 minus 3 gets 2. That is correct. So this is going to be table B. Grandma shows up 3 hours earlier than I tell her to come. So if she arrived at 2 p.m., I must have told her 5. I must have told her 5, because 5 minus 3 gives us 2 p.m. Okay? So that's going to be B and J, and then the graph is our last mission here. So again, what I'm trying to figure out, I have y equals x minus 3. We have a couple of points that I can test. Well, that was supposed to be positive 1, negative 2, and then 5, 2. So, if you look at these graphs, again, each of these is a point. But as I mentioned, a graph, the line specifically, is like all the points connected. Each point can be plugged into this relationship. Okay? That's the purpose of this. This communicates the relationship. So this is why you're going to learn equations that have a y and an x. But in order to be able to use it, we can illustrate it with a graph. That's all a graph is, okay? It's a picture of an equation. Say that one more time. A graph is a picture
of an equation.
I don't have to say it again. Okay. So if you search through these 4 graphs, the only one that has these points on it, 1, negative 2, and 5, 2, end up being right there. So that's what I mean by on the graph. It's on the line. Remember, the line is just a collection of all the points that belong to that rule. Okay? So let me just give you one other test here. Look at where 0, 0 is, right? Is 0, 0 on the line? No. Therefore, 0, 0 should not satisfy this relationship. If you plug in 0 for x, do you get 0 for y? No. So it's not on the line. Okay?
What if there's one that says y equals x?
Then that means x is the same as y.
What does that do?
It would make a graph where all the x's are the same as the y values. 1, 1, 2, 2, 5, 5. Negative 10, negative 10.
1 will be 1.
What?
1 will be 1.
Okay. So, I think I've given you enough to finish this. Okay? So, finish this along with your Delta Math and the homework for this lesson. Okay? There is Delta Math this week.
That's okay.
All right? And I'll see you guys on